Now I want to actually talk through the homework in the practice section related to power because it is something that's a little more complicated for folks. So let's look at part A here. This is our hypothesis. The true proportion is 10%. I have this curve up here. Do know that the mean of this distribution here is at 10%. We think the hypothesis is less than 10. So my alternative has to go to the left of this graph because we think it's smaller than 10. Actually up here they said the alternative should be 0.08 and they're saying it gives you a power of 64%. So this curve here, the mean at this one is at 0.08. Again, if this is at 10, this would be at 8 on the number line. So if we drop that alpha of 5% straight down, this is the power right here of 64%. So by definition what it means, it's our probability that H sub O will be rejected, because anything to the left of this alpha gets rejected. So that's all rejected, given a specific alternative is true. So that's what the 64% means. Now this says you could get higher power against the same alternative with the same alpha just by changing the number of measurements you make. Should you make more measurements or fewer measurements to increase the power? So they are basically saying, what are you going to do to the sample size, right? Well, if you remember the connection, what we had said is we said as your sample size increases, your power will increase. Now, what's the rationale behind that? Look at this analysis. So this is the scenario where we had 5% for our alpha, and I chose a sample size of 910. So at 910, the power is 0.64. So what happens if I increase the sample size to 1200? Well, the power in this case actually went up to 0.76. Why did it do that? Well, if you think of it this way, remember this is the initial curve. Well, when you increase sample size, you reduce variability, which means this curve is going to kind of tuck itself in and become less variable. So as it tucks itself in, this moves over, which is actually going to cause the alpha level to actually move over too. So as alpha moves over this way, it's going to push itself that way and give us a little bit more power on this side. So you see here more black, here you see less black because moving the alpha line causes our power to increase. In this one, we decide to change the alpha to use 0.01 instead of 0.05. Well, if you remember, you can just make that connection too. So in this case, what they did is they took alpha and they reduced it. Well, again, I think the easiest way to do this is remember that alpha is your type 1 error. And that type 1 and type 2 go hand in hand. So if the type 1 error goes down, the type 2 error has to go up. If this goes up, it's going to actually cause this power to move down. You do see this in this scenario here. Be careful. This is our alpha of 0.05. We're just going to take that alpha of 0.05 and move it over to the left. Well, as it gets moved over to the left, it cuts off some of that power and we get less power. Part D here, you shift your interest to the alternative of 0.07 with no other changes. Will this increase or decrease power? Now remember, we thought the alternative was 0.8, but now we think it's 0.7. So what that's going to do is if you look at the graph, again, here's our 10%, this is 8%. Well, we think this graph should be at 7%. So let's take this entire curve and move it to the left. Well, if you shift this to the left, you're going to end up getting more green in this region because this black will get covered up with the green power, and you're going to see that your power will actually increase in terms of that.